Assalamu alaikum. Am I audible?
Walaikum assalam, sir. Yes, sir, you're audible.
Any doubt from last class to anyone of you?
No, sir.
Okay. In last class, I defined you how to calculate Reynolds number and on the basis of which how to define different types of flow. Let me define you its other relation. There is a term which is called rate of flow of liquid, denoted by Q, which is equals to volume of liquid flowing per unit time. Volume is area of cross section into length divided by time taken. So this x by t will be termed as velocity. So it will be A into V is equals to Q. So rate of flow of liquid Q is equals to area of cross section into velocity. In the above part, in terms of Reynolds number, may change the value of V in terms of this Q. So we may write V equals to Q divided by A. Area of cross section of that tube having diameter D will be pi diameter square divided by 4. So by putting in this velocity in the above expression, you will get the Reynolds number rho V D divided by eta equals to 4 times rho into Q divided by pi eta diameter D. So this will be another expression of calculating Reynolds number in terms of rate of flow of liquid or Q. Hamza, is it clear?
Yes, sir.
We may define Reynolds number in some other way also. Reynolds number is equals to rho Vd divided by eta. Rho density, just 1 minute. We have two different forces. One is called inertial force, force due to mass of a body or moving mass of a body, divided by viscous force due to Newton's law of viscosity between layer of liquid. Inertial force is mass times acceleration. Viscous force is eta, A, velocity by length. In terms of this, it will be D. Which will be further, mass is equals to density into volume. Volume would be area into length. Acceleration, it will be velocity divided by time taken. Eta, A, velocity by diameter. Is it clear till this part? Any doubt in this expression?
No, sir.
Okay, now this part and this part will cancel out. This part and this part will cancel out. This x by t will define your velocity. So it will become rho v. This diameter will move to numerator d divided by nothing but eta. This will be equivalent to Reynolds number. So from this, we can say Reynolds number is also a ratio of inertial force and viscous force. Khalid, is it clear?
Yes, sir.
Okay, just write it down. Okay, Salman. You'll have written.
Yes, sir. Done.
Next is Stokes law. In the above part, Newton's law of viscosity, we have defined the amount of viscous force between layer of liquid. But in this part, Stokes law, it defines the amount of opposing force experienced by any solid object when it is projected in viscous medium. Suppose you have a ball of radius r, which is projected at some velocity v in any viscous medium. So how much would be the viscous force or opposing force experienced by it in this viscous medium? It will be defined by Stokes law. So related to this, when a body is projected in viscous medium, it will experience an opposing force called viscous, which depends upon first coefficient of viscosity of liquid, coefficient of viscosity of liquid, that is eta. radius of body r, and its velocity v. So on the basis of these three different parameters, we have to calculate viscous force. So let me define you according to concept of dimensional analysis. You will say viscous force equals to some proportionality constant k and its depending factor eta having exponential x, radius y, and velocity z. So this will be a generalized expression for this force experienced by this object. Hamza, is it clear?
Yes, sir.
Now just tell me what we'll do next to calculate the value of x, y, z. Iba, what we will do next to find the value of x, y, z using this expression? You'll say, write the dimension of each quantity on both sides, then compare the exponential of same term, and you will get the value of x, y, z. Okay, Hamza?
Yes, sir.
So for f, dimensional formula will be mlt raised to minus 2. K being proportionality constant, it will be unitless quantity, neglected. Eta, coefficient of viscosity, ml minus 1, t minus 1, raised to x. R, radius with being as length, y, velocity, lt minus 1 to the power z. So on rearranging, you will get m raised to x, l raised to minus x, plus y, plus z, and t raised to minus x, minus z. Khalid, any doubt?
No, sir.
Now just try to compare the exponential of each term, then find the value of x, y, z. Just write it down. Try to find the value of x, y, z. Good, Hamza. Khalid, you got any answer?
Yes, sir.
Just send me. Good. Okay. Now, proportionality constant K, which is equals to 6 pi. Put this down. On comparing, you'll get m having exponential x in left hand side 1. So on comparing the exponent, x will be equals to 1. For length, we have minus x plus y plus z equals to 1. And minus x minus z equals to minus 2. So put the value of x to be 1. So minus 1 z equals to 1. Put these two terms in this expression, you will get y equals to 1. Now, put the value of x, y, z and k in the above expression. You will get f equals to 6 pi eta to the power 1, radius to the power 1, and velocity to the power 1. So this will be your final expression of viscous force experienced by any object in viscous medium. Good, Hiba. Now, in this part, these terms 6 pi eta r will be constant for a particular object. Only velocity of object may get changed due to viscous force. So we can write this quantity is the factor which is responsible for opposition of object in that viscous medium. So it is also called damping factor, denoted by B. So we may write the above expression as force is equals to B times some velocity V. And since this force is opposing nature, so there will be some negative sign. Hamza, is it clear?
Yes, sir.
Okay, just write it down. Nikhil, any doubt? Okay. You all have done?
Yes, sir. Done.
Okay. Now on application of this Stokes law, let me define you a term. Terminal velocity. Suppose you have a body any spherical object of radius r, which is thrown in any viscous medium under the effect of gravity. Like this. Khalid, just tell me what will happen to its velocity initially, whether it will increase, decrease.
Sir, like when it's falling down or in the
Yes,
surface?
when it is dropped from this surface.
Sir, its velocity will increase.
Good. So on increasing its velocity, whether viscous force will increase or decrease.
Viscous force will increase.
Good. So initially it is acted upon by gravity towards downward direction, which will tend to accelerate this object through this viscous medium. So on accelerating through this medium, it may attain some velocity, and on increasing velocity, viscous force experienced by this object may also be increasing. At some instant, let's say at this instant, it must have achieved some velocity, for which if we have to calculate force acting on it, so it must be acting a force along this direction, viscous force, and since it is placed in any viscous medium or any fluid, so it must be experiencing buoyant force and another one in downward direction, weight due to gravity. Hamza, is it clear?
Yes, sir.
So if net force acting on this particular object becomes zero, let's say total upward force and total downward force becomes equal. So will there be any acceleration to this particular object?
No, sir.
Good. So you will say the velocity of object becomes constant. So this constant velocity with which object will ascend or descend in any viscous medium is termed as terminal velocity. Is it clear?
Yes, sir.
Yes, sir.
So terminal velocity is the constant velocity with which a body may ascend or descend in viscous medium. So at this point, since velocity is constant, so acceleration of body at this instant will be zero. So net force acting on the object must be zero. So total upward force, total downward force, viscous force is 6 pi eta r times velocity. Buoyant force is density of medium times volume of object times gravity. Weight of object is density of object volume of object times gravity. Move this term to right side. So you're left 6 pi eta r Vt equals to, take out 4 pi r cube common. So you're left with sigma minus rho times gravity. So terminal velocity on solving this expression will become 2 times r squared by 9 times eta bracket sigma minus rho times gravity. So this will be your final expression of terminal velocity in terms of radius. Hamza, is it clear?
Yes, sir.
Nikhil, any doubt? Okay, just write it down.
Done, sir.
Done, sir.
Okay, so this is one way of expressing this terminal velocity in terms of radius. Let me define its other expression. Suppose you may write this term as 6 pi eta r times terminal velocity equals to, move this bar first to right side. So weight of object is sigma, volume gravity minus rho volume gravity take out rho Vg, sigma Vg as common. So you're left with 1 minus rho by sigma. This quantity will be mass of object. So terminal velocity in this case will become mg divided by 6 pi eta into r bracket 1 minus rho by sigma. So this will be terminal velocity in terms of mass of object. So you'll be given either in terms of radius or either in terms of mass. Khalid, is it clear?
Yes, sir.
Now there will be graph related to this entire expression. Let's say this is any constant velocity. Object will attain after some time, which is also called terminal velocity. Along this direction, velocity, and along this direction, height or time. So in first part, if a body is projected or initially dropped, it may acquire this curve to attain this velocity after some time. In this part, initial velocity of object is 0. In second case, if body is projected at some initial velocity but smaller as compared to its terminal velocity, so it may acquire terminal velocity after some time, this greater than 0 but less than terminal velocity. If a body is projected at some higher velocity greater than its terminal velocity, so it may acquire after some time like this. So in this, initial velocity is greater as compared to terminal velocity. So in all of these three cases, object will tend to acquire terminal velocity after some time, whether it is projected at some smaller velocity or larger velocity. Hamza, any doubt?
No doubt, sir.
Okay, just write it down. You all have written?
Sir, drawing the graph.
Okay.
Done, sir.
Done, sir.
Okay. Now let me define you problems related to this part. Suppose you have small n number of raindrop, each falling down at some constant terminal velocity v1. If they combine to form single large drop, what would be terminal velocity for this single large drop? We have to calculate it. Combination raindrop. Let's say volume of object initially must be equals to volume of object finally. We have n number of small drop. each having volume 4 by 3 pi r cube, which must equals to volume of single drop 4 by 3 pi r cube. So on solving, you will get r equals to n to the power 1 by 3 times small r. In the above part, we have two different formula for terminal velocity. One is term of radius only, and the other in terms of mass. So you'll say in this combination, mass of object is changing from one part to another. Since small drop, each having mass small m, and we are n number of drops on combining, we have total mass n times m. So instead of calculating in terms of mass, it will be easy to calculate in terms of radius. So velocity equals to 2 times r square divided by 9 times eta bracket sigma minus rho times gravity. So in this part, 2, 9 eta, sigma, rho, gravity, all are constant, only r is changing. So we can say velocity is directly proportional to r. So v1 divided by v2 must equals to r1 divided by r2 whole square. Now put the value of r1 to be initial radius of raindrop. So it is just r. Final radius on combination becomes n to the power 1 by 3 times r whole square. So it will become r and r cancel out. So you're left with 1 by n to the power 1 by 3 whole square. So it will become n to the power 2 by 3. So on cross multiplication, you'll get v2 equals to n to the power 2 by 3 times v1. So this will be your final expression of single drop as compared to each individual drop. Iba, is it clear?
Yes, sir.
Okay, just write it down. Nikhil, any doubt? Okay.
Done, sir.
Salman, any doubt?
No, sir, no doubt for now.
Okay. If raindrop are falling at constant velocity of 2 centimeter per second. Now, if 8 drop combines to form single, find its terminal velocity. Just use the above formula, put the value of n to be 8. V1 is given, simplify it. Hiba, you got any answer?
No, sir, I'm doing.
Just say we have number of drop 8 and velocity of each drop initially is just 2 centimeter per second. So put these two terms in the above expression. V2 will be equals to n 8 to the power 2 by 3 times V1 2. How to calculate this part? We may write 8 in terms of 2 as 2 to the power 3, which is further raised to 2 by 3. So power to the power will get multiplied. So it will become 3 multiplied by 2 by 3. So this part and this part will cancel out. So you'll get 2 to the power 2, that is 4. So 4 into 2, it will become 8 centimeter per second. Hamza, is it clear?
Yes, sir.
Khalid, any doubt? Okay, just write it down. Hiba, done?
Yes, sir.
Next is equation of continuity. Suppose you have a tube of different cross-section area. Area of this cross-section is A1, area of this is A2, in which incompressible and non-viscous liquid is flowing. Let's say velocity of each layer at this instant is V1, since there is no viscosity, and this velocity of each layer is V2. So we have to define relationship between these two terms, or non-viscous liquid is flowing in a tube of varying cross section. So first, mass of liquid entering into this particular tube per unit time. So it is mass divided by time taken. So mass is equals to density into volume. So we may write density into volume. It will be area of cross section into length divided by time taken t. At first instant, area will be E1 and length L1. So x1 by t will be also equals to velocity of liquid at first instant. Khalid, is it clear?
Yes, sir.
Similarly, we may write mass of liquid ejecting out per unit time. So it will be density into area into velocity at second part. Now, according to conservation of matter, you will say mass of liquid entering from one part must equals to mass of liquid ejecting from the other part. Okay. So using conservation of matter, we can say mass of liquid entering per unit time will equals to mass of liquid ejecting per unit time. Hiba, any doubt?
No, sir.
Now put the value of both these two terms related to the above part. So it will be rho A1 V1 must equals to rho A2 V2. So rho and rho will cancel out. So we'll get A1 V1 equals to A2 V2. Or we may write product of area of cross section times velocity, which is also called Q, which is also called rate of flow of liquid, is always constant at any instant for the flow of non-viscous incompressible liquid. So the graph related to these two terms for area of cross section versus velocity will be inversely proportional to one another. If area will decrease, velocity will increase. If area will increase, velocity will decrease, and vice versa. Hamza, any doubt?
No, sir.
Okay, just write it down.
Sir, could you scroll down? Done, sir.
Done, sir.
Done, sir.
Nikhil, any doubt? Now let me define your question related to this part. Suppose you have a tube like this. Let's say velocity of liquid in this cross-sectional area is 5 meters per second. Area of tube is A. In this part, velocity of liquid is 3 meters per second. Area of cross-section is A. Now suppose this particular junction having 20 holes, each having area A by 5. Find velocity of ejecting liquid. Through this hole. So let me define you how to use this part. According to the above concept, equation of continuity, you will say this part through which liquid is entering to this junction, and this part liquid is entering through this particular junction, and only through this part liquid is ejecting out. So according to conservation of matter, total amount of liquid entering must equals to total amount of liquid ejecting. So A1V1 plus A2V2 must be equals to, we have n number of holes, each having area A3. So the velocity of liquid ejecting will be V3. Put the value of each part and simplify it to find V3. Is it clear? Hamza, any doubt?
So what do we put in area?
You have given. For first part, area is E, so A1 will be A. For second part, area is it's still A, so it will be A. For third part, area is A by 5. Okay. N is number of holes here, which is 20. Just put all the values and simplify it. Khalid, you got any answer? Salman?
Yeah, sir, keep going.
Let's say we have area A1 as A, velocity in this segment 5. A2 is still A, velocity in this segment is 3. Number of holes 20, each having area A by 5, velocity V3. So 5A plus 3A, it will become 8A equals to 5 into 4, 20, 4A times V3. So V3 will be equals to 8A divided by 4A, which will be just 2 meters per second. Good, Hamza. Any doubt? Salman?
No, sir, no doubt.
Hiba, you got this or something else?
Yes, I got it.
Okay. Now there will be a question related to this concept. You often have observed, suppose there is a tap which may be at some height. So if you open this particular tab and try to observe the shape of stream of liquid coming out of it. So it must be like this. Okay, Hamza? Is it clear?
Yes, sir.
So my question is, why width of stream on falling down decreases? Why width of stream of water decreases on falling down? Khalid, any guess?
Sir, maybe something related to viscous force.
Just assume there is no viscosity. Then Suppose this particular position to be initial position. So on falling down, this liquid may attain or may go through some height. So on falling down through this particular height, the velocity will increase or decrease. Suppose the particle which is falling freely under the effect of gravity. Good. So on increasing velocity, according to equation of continuity, you will say area of cross section and velocity at any instant will be always constant. And since in this part on falling down, velocity of liquid increases with increase in height. So you say area must decreases. So the product of area and velocity at any instant should be constant. Is it clear?
Yes, sir.
So you'll say as area of cross section times velocity will be constant, and in falling liquid, velocity is equals to root under 2gh. So height increases, velocity of liquid increases, hence area of cross section decreases. Khalid, is it clear?
Yes, sir.
Salman, any doubt?
No doubt, sorry.
You all have written?
Yes, sir. Done.
Nikhil, any doubt? Next is most important part of this entire chapter, Bernoulli's principle. You'll be asked to derive this particular principle and a statement in your upcoming final exam. Let me define you what state. Suppose you have a tube of varying cross-section area like this, and whose end is at different level. Let's say this is horizontal level and velocity of liquid at this instant is V1, area of cross section A1, area of cross section at this instant A2, velocity of liquid at this instant is V2. Now, height of tube at this point H1 and at this point H2. So according to Bernoulli's principle, it's said there is particular limitation. One, liquid should be non-viscous. Second, it should be incompressible. Third, energy should be conserved. And fourth, there will be no variation of gravity due to change in height. It means H1 and H2 should be very small so that gravity should be constant. So at any instant for the flow of this liquid in this tube, sum of pressure, kinetic energy per unit volume, and potential energy per unit volume would be always constant. So according to this Bernoulli's principle state, for non-viscous, incompressible liquid flowing in a tube, the sum of pressure, kinetic energy per unit volume, potential energy per unit volume at any instant will be constant. First, write it down, then I'm proving it. You will say there is some limitation to this law. First is liquid should incompressible. It should be non-viscous. Gravity should be constant. And energy should be conserved. Okay, just write it down. Salman, done?
Yes, sir, done.
Okay. So in this part, if I ask you, which of the factor will be responsible for the flow of liquid from lower end to higher end? Is it possible to flow liquid from lower end to higher end? You'll say no. So there should be some external agency which will be capable of flowing of liquid from some lower end to higher end. Okay. So to overcome or to fulfill that part, let's say pressure applied at first end is P1 and at second end is P2. This pressure difference will be capable to flow from lower end to other end. So it will exert or it will do some work on this particular system to move liquid from lower end to higher end. So let's say work done due to pressure difference. Work done is equals to force times displacement. We may write force in terms of pressure as net pressure into area into displacement. Area into displacement is called volume. So it will become P1 minus P2 into volume V. Now this work done or external work done will be capable of flowing liquid from lower end to higher end. In this part, liquid is going from lower end to some higher end. So there should be some change in potential energy. And there is change in velocity of liquid from one having larger width to the other having smaller width. So there should be change in kinetic energy as well. So according to work energy theorem, we can say according to work energy theorem, amount of work done due to pressure difference equals to change in kinetic energy, change in potential energy. Now, work done is P1 minus P2 multiplied by volume. Change in kinetic energy is half m final velocity V2 initial velocity V1 plus change in potential energy mg final height minus initial height. Hamza, is it clear?
Yes, sir.
Now move this volume to right side. So you will get P1 minus P2 equals to half mass divided by volume multiplied by V2 square minus V1 square plus mass divided by volume gravity H2 minus H1. So in this part, mass divided by volume, this quantity and similarly this quantity will become nothing but density. So we may write P1 minus P2 equals to half rho V2 square minus half rho V1 square plus rho G H2 minus rho G H1. Move same term to one side and rest of the term to other side. So you'll get P1 plus half rho V1 square plus rho G H1 equals to P2 plus half rho V2 square plus rho g h2. So both are same term along both sides, only there is change in subscript. So we can write pressure plus half rho v square and rho gh at any instant for the flow of non-viscous incompressible liquid is constant. Hiba, is it clear?
Yes, sir.
So this is pressure, this is kinetic energy per unit volume, and this is potential energy per unit volume. Sum of these terms at any instant for the flow of liquid is constant. Okay, just write it down.
Sir, could you scroll down a bit?
Done, sir. Done, sir.
Okay. For this particular above part, may break this component in some other form also. Divide this entire term by rho into g. You will get pressure divided by rho times g plus velocity square by 2 times g plus h is equals to constant. So this is some different form of Bernoulli's principle. In this part, the first expression is P by rho into G. It is termed as pressure head. Second term, velocity square by 2 times g. It is called velocity head. And third, just h. It is called gravity head or gravitational head. So you may be asked to calculate velocity head for any particular flow of liquid. So you must know what do you mean by velocity head. Okay. Why I've just divided this entire term by rho into g, since rho is density of liquid, so it should be constant, and g is gravity, which is also constant. So only these two terms is in this entire segment is constant. So I just divided from each part. Hamza, any doubt?
No, sir.
Just write it down. Any doubt till this part?
No, sir.
Done, sir.
Okay. Now let me define you calculation on the basis of its application. First application is upliftment of aeroplane. Let's say airplane which is running on a runway. First, so air incoming from front side may move along this path like this. And from bottom on hitting its surface may get stopped. So due to this entire segment, you will say velocity of air at the upper region increases and velocity at bottom will decreases. Is it clear?
Yes, sir.
According to Bernoulli's principle, we have pressure plus half rho v square plus rho gh is equals to constant. In this part, height is constant almost for the upper part and lower part. So we're left with just two segments, pressure and velocity. So if velocity is decreasing, this entire term will increase. As a result, pressure on that region will tend to decrease, so that sum of these terms at any instant should be constant. So in the lower segment, velocity is decreasing, so pressure must be increased. In the upper part, velocity is increasing, so pressure must get decreased. Is it clear?
Yes, sir.
Let's say the upper region is first and the lower region is second. And due to this pressure difference, it will be capable of uplifting in the entire term. Or you say due to this pressure difference, it will capable of uplifting this entire term. So using Bernoulli's principle, pressure on first part, half rho V1 on first part, rho GH equals to pressure on second, half rho V2 on second, and rho GH. Since there is no much difference in height, so this part and this part will cancel out. Now, in lower side, pressure is more, that is P2. So move P1 to right side and this of the term to left side. So 1 by 2 rho V1 square minus V2 square equals to P2 minus P1. This term, net pressure, will be capable of uplifting this entire term. So pressure will equals to force divided by area. So we may write this left term in terms of A square minus B square as A plus B times A minus B divided by 2 equals to pressure equals to force by area. Force is mass of the system times gravity divided by area of cross section. Now in this part, this entire quantity is nothing but V1 plus V2 divided by 2. So it will be termed as average velocity. And this particular quantity will be termed as change in velocity. So if you have to calculate how much will be change in velocity between lower segment and upper segment during this entire segment will be delta V mg divided by rho into area into average velocity. So this will be expression of calculation of change in velocity between two layers. Hiba, any doubt?
No, sir.
Salman,
Yes, sir, done.
any doubt?
No, sir.
Okay, just write it down. Hamza, done?
Yes, sir.
Khalid, any doubt?
No, sir.
Similarly, as I have just calculated in this part, there will be calculation in terms of upliftment of rooftop of any hut. Suppose so in heavy storm, air will move across this from its rooftop like this. So velocity of air at this point will increases, and inside this particular house, velocity of air will be 0. This change in velocity will be capable of changing the pressure between inner part and outer part. So outer segment pressure will decrease and inner part pressure will increase. This pressure will be enough to uplift this entire rooftop. So we may calculate how much pressure, force, or velocity of air should require to uplift this entire segment using Bernoulli's principle. So in this part, P1 plus half rho V1 square must equals to P2 plus half rho V2 square. Let's say this is first part and this is second part. So in this part, P1 is greater as compared to P2. V1 is 0. So this entire term is 0. So you're left with P1 minus P2 equals to half rho V2 square. This particular term, pressure, will be equals to force by area. Force is mass of that roof times gravity by area of cross section equals to half rho V2 square. So if you have to calculate velocity, so it will be root under 2 times of m into g divided by rho into a. So this much amount of velocity of storm should be required to uplift this rooftop. Is it clear?
Yes, sir.
Hiba, any doubt?
No, sir.
Let me give you a question related to this part.
Sir,
Yes.
so what if there is some velocity inside the house?
So we may difference these two terms to find.
Okay, sir.
Try to find this part using what I have derived above for plane.
Sir,
Yes,
if it we convert 900 kilometer to meters?
yes. 900 kilometer per hour, just multiply it by 5 by 18 to convert it into meter per second.
Okay, sir.
Khalid, convert this velocity in terms of meter per second first, since the rest of the whole quantity is in SI unit. Put the all values in this part. Take gravity to be 10 and simplify it. Khalid, just check your calculation. It will be around 2 point something. Mass is 2 into 1000. Gravity is 10. Density is 1.3. Area of cross section 25. Velocity is 250. So 250 in 4 times become 1000. 5 into 2 and 5 into 5. So you'll get 2 into 4, 8 into 2, 16. Divide by 5 into 1.3. So it will be 3.2 divided by 1.3. So 13 2s are 26.60, 13 4, 52 806. This much. Hamza, you got this?
No, sir, I got some different answer because of I had mistake in the conversion.
Okay, okay. Khalid, any doubt?
No, sir.
Okay, you all have done?
Yes, sir.
Yes, sir.
Okay, just stop here for today. I've just left one part of this application of Bernoulli's principle. Next class, I will define you that part, and then we will start the next chapter, that is thermal properties of matter. Okay.
Okay, sir.
Okay, then take care. Allah Hafiz.
Thank you, sir.
Okay, sir.
Allah
Allah
Hafiz.
Hafiz.